All right, today we're going to tackle a concept that, I promise, will completely level up your Arduino projects. We're moving beyond the simple delay function to write code that's way more responsive, way more powerful, and can actually do more than one thing at a time. You know that feeling, right? You've built something where you need to blink an LED and read a sensor, but it just feels clunky. The project seems sluggish, it misses button presses, and it just doesn't work the way you pictured it. Well, there's a super common reason for that, and we're about to fix it for good. So here's the game plan. We're going to start with the function we all know and love, delay. Then we'll dig into why it's actually a huge problem. After that, I'll introduce you to its much cooler, much more powerful alternative, millis. We'll see exactly how it works with an example, and then, for a little bonus round, we'll touch on some high-speed options you might need down the line. Delay. We all start here, right? The classic Blink sketch is pretty much the hello world of the hardware world, and delay is the star of that show. It's simple, it gets the job done, but to really understand why we need to move past it, we have to look at what it's actually telling the Arduino to do. And that last part is the absolute key. When your code hits a delay command, the microcontroller just stops. It completely freezes. It's not reading sensors, it's not looking for button presses, it's not doing anything at all. It is literally taking a nap for the exact number of milliseconds you told it to. And get this, the delay function can hold a massive number, up to 4.2 billion to be exact. What does that mean? It means you could literally tell your Arduino to freeze itself solid for almost 50 days straight. Now, you probably don't want to do that, but it really shows you what this function's one and only job is, to just sit there and wait. Okay, so if it's so simple, what's the big deal? Well, that little nap we were just talking about, it can have some pretty disastrous consequences for any project that needs to, pay attention to the real world. This right here explains the problem perfectly. What you want is for your code to be fluid, right? You want it constantly checking its sensors while it's blinking that LED. But delay forces everything to stand in a single file line. It's what we call a blocking function. It has to finish its nap completely before it will even think about looking at a sensor. And this is exactly why it matters. Think about a robot that's supposed to avoid obstacles. If you have a 2-second delay anywhere in its main loop, that robot is effectively driving completely blind for 2 whole seconds. By the time it finally wakes up to check its sensors again, well, it's probably too late. You've got a crash. That's the danger of blocking code. So, how do we fix this? How can we manage time in our code without bringing the whole thing to a grinding halt? Well, it's time to meet the hero of our story, the millis function. Okay, think of it this way. Delay is like an hourglass. You flip it over and you just have to stand there and wait for all the sand to run out. Millis, on the other hand, is like a stopwatch. It starts counting the second you power up your Arduino and it never ever stops. You can just glance at it whenever you want to see how much time has passed, all while you're busy doing other things. So let's break it down. First, and most importantly, it does not pause your program. It's non-blocking. It uses that same giant number type we saw before, so its internal stopwatch will keep on ticking for about 50 days before it overflows and rolls back to 0. That's a little detail you gotta remember for any projects that are gonna be running for months on end. Theory's great, but let's actually see how this works in practice. We're going to rebuild that Blink sketch, but this time we'll do it the non-blocking way, which means our Arduino will be totally free to do other stuff while that little LED is blinking away. The whole secret sauce to using millis is this little piece of logic right here. Instead of telling the code to pause, we're just going to constantly ask it a question. The question is, hey, has enough time passed since the last time I did this task? We just check the current time on our millis stopwatch, subtract the last time we did something, and if that difference is big enough, we know it's time to act. Let's trace it out. So at the very beginning, our previous time is 0. Now, the loop is running like crazy, thousands of times a second, and the current time from millis is just ticking up. At 500 milliseconds, the difference is 500. Is that bigger than our 1,000 millisecond goal? Nope. How about at 999? Still nope. So the condition is false, the code inside the if statement gets skipped, and the loop just keeps on spinning instantly. And then bam, the millis stopwatch hits 1,000. Now our math is 1,000 minus 0, which is 1,000. Is that greater than or equal to our 1,000 interval? Yes, it is. The condition is finally true. And at that exact moment, the code inside our if statement, the part that toggles the LED, finally gets to run. So the whole pattern is really that simple. First, you check the time. Second, if enough time has passed, you do your thing, like blink the light. And third, This is the most important step. You immediately update your previous time marker to whatever the current time is. That resets the clock for the next interval. And the loop itself? It never, ever stops. It's free to check buttons or read sensors thousands of times between each and every blink. Now that we've totally mastered milliseconds, let's take a quick peek at its super fast relatives. These are what you'll need when you're dealing with events that happen way, way faster. This table lays it all out pretty clearly. Just like millis is the non-blocking big brother to delay, micros is the non-blocking version of delay microseconds. It counts in microseconds, that's millionths of a second, and it is perfect for really high-frequency stuff. Just notice that its timer resets a lot faster, only after about 70 minutes. And here is a fantastic, super cool trick you can do with delay microseconds. See, normally you need special PWM pins to do things like dim an LED, but by using really, really short and precise blocking delays, like turning a pin on for a few microseconds, then off for a few hundred, you can actually create your own PWM signal on any digital pin you want. It's a great little hack to keep in your back pocket. So if you only take one thing away from all this, let it be this right here. Writing blocking code with delaying is like forcing your program to sit in a waiting room. It's just stuck. It can't do a single thing until its name is called. But writing non-blocking code with millis is like giving your program a watch. It can keep on working, keep on doing its job, and just glance at its watch every now and then to see if it's time to do something else. Seriously, this technique opens up a whole new universe of possibilities. We're talking responsive interfaces, complex robots that can think and act at the same time. It's really the key to unlocking what your microcontroller can truly do. So the only question left is, what are you going to build with it?